Hey everyone, welcome back to my YouTube channel. Yep. As you can see in this design here, I will be creating Terraform resources that will create the EC2 instance and then give it a security group that we will assign to it. And then when we assign that security group to it, it will enable anybody from the outside world to be able to access the application that we will put inside of it. A quick rundown. What I will be doing here will require me to demo this session using the Terraform specified what is it called? The Using the Terraform specified best practices. I pray you find this video helpful. Again, even though this diagram involves the S3, I will show you guys how I created the S3 using a cloud formation. But at the end of the day, what I will be displaying here is the technique on how to send our locally TF state files to a backend that is going to be within the cloud, which we will store in S3 as uh, as intended in this particular demo. So I pray you find this video helpful. If you want to follow this, I pray that everything will run perfectly well at the end of the day. When I'm posting this out, I'll put the GitHub repository for this project inside of it. Let's get started. So the first thing I'm going to do is to create a folder, and that folder I named it first config, and then I will go inside of that folder and then change from this particular screen in my VS Code, and then I'm pulling up the folder right now that I just created, first conf. I pull it up. So as you can see, that folder is very empty, and I'm opening the terminal. Terminal is open right now, and then we will start putting our code in. Let me reopen this because the copilot for some reason came out. Yeah. So this is the Terraform configuration documentation page. I like to work with it and reference it directly from there. So what I will do now is to create the first file, which will be terraform.tf file. And in that file, I will put in the Terraform required folder. And as you can see, it's going to be the AWS, and the source is HashiCorp/AWS. The version is going to be 6.0. Now let me get the AWS instance documentation page to be able to guide me and also help you to understand how I am going to be writing this configuration. And yep, I can see the AWS instance right there. I pull it up, and this is how the basic example using AMI lookup is going to look. So I will create my main.tf. And in that main.tf, we saw the file, but the first thing I'm going to create is going to be the resource, and the main thing is the AWS instance. So it will be resource AWS instance, and then I will name that instance test, and let me put it there as test. And then the instance type, it will be T3 micro that I want. And the AMI is something that we will have to reference because we'll bring it in from the AWS, um, AMI market. So I will just import the data and through a Terraform data operation, which is now different from the resource. And as you can see, I'm picking it, everything just the way it is. And then I will name this test AMI. And while referencing this in the resource instance block, I will um, be definitely using it inside of line 3. But let me continue to define this first. Putting the owners is going to be Amazon. And then I'll put in some filters. So the name of the filter is going to be architecture. And then the value is x86 underscore 64. And then I'll add another filter. And then the name will be name, then the values will be, I've used the 2023 Amazon Linux, but let me change it to 2024. And, if it fails, then we know that 2024 is not ready yet. And then I'll come back to 2023. The last time I used the AMI, I remember clearly, was the 2023 Amazon Linux that I was using. But yeah, that's the image that we will create that EC2 instance off of. And I have just declared it right now. I'm adding the most recent to true. So anyone that I want the most recent one of it to be true. So what do I do now? I will clean up this and then put the data dot AWS underscore AMI dot test AMI dot ID. And that is how I declare the image I'm going to boot up that instance with. Let me try to do maybe a Terraform plan now, or Terraform init, because I've not initialized Terraform in this folder. So it's initializing now, as you can see. The backend is going to be created locally, and you can see additional 2 files that it created. Let me log into my AWS I will do the AWS configure command. And then let me clean out this with the terraform fmt command, and you can see everything looks clean. Validating it to make sure that the configuration that I put in is good, is success. And as you can see, that green success is going on. So let me plan it then. Terraform plan. And then Terraform plan is just a dry run that will tell us what we are going to. Oh, it threw an error. And that error is within my Amazon machine image. It says it's line 7, which is the in the data Amazon machine image. The only thing that I know that I did not do right is the guessing of the values in the second filter. So I am assuming that that is why this plan failed. Let me correct it to the one that I'm sure that it will use, and then rerun this plan to see if that was the problem. But 100% that should be the problem. Good, that was the problem. So when we go up, or when I go up, you will see the Terraform plan, and the resource that is about to create is going to be an AWS.test. That is how I stipulated it. And then the instance type will be T3 micro, and the region, I did not specify that. So I picked the US East one for me. And then the security groups, we are not defined yet. So it's going to, we are going to know the security group after this has been created. Yes, Terraform apply, yes. And it's creating it now. Shouldn't take that long. Good. One resource added. We are now in our AWS console. Let's check the EC2 instance. It should still be initializing. So you can see, instance state is running. I will have to clear out that to see the instance that I was using that should be terminating right now. Is running, but the status check is still initializing, so it's not ready yet. Okay, I'm waiting for it to finish initializing, but if that is still taking some time, then we might just proceed to continue the configuration while that initialization is still going on. As you can see, the status check is still initialized. Yeah, back to my Visual Studio Code. Let's continue to go. So the next thing is, this is an Apache server that I'm creating. So I'm going to put my user data inside of this folder, first config. So what I did is mkdir scripts, and then I am inside of the script folder using the change directory, and then I am creating a user data.sh file where my user data will be in. And I already have everything, but let me walk you down what I will be doing. I will be telling this script that this is going to be a bash script with /bin/bash, And then the first thing I will do is to update this system while it runs. So sudo yum update. And then after that, dash y will, put in yes in any place that it prompts us. Then I will do the same sudo yum, but this time around install httpd, and we're targeting the httpd x86 underscore 64. Okay. And then I am doing the sudo start service command, which is start httpd dot service, and then I will enable that server using the sudo systemctl enable httpd dot service. That's about it for this file. So what I'm doing here is to install the httpd service, and then I am done. So here I will have to put in that user data for this EC2 instance to see it. And then what I need to do is to come here in my Terraform documentation page and then Control F to search for user data. And as you can see, I can use user data when launching the instance, but I don't have to pass in a gzip compressed data through this argument. So I'm not gonna do that. I'm going to just pass in the user data. And usually you're gonna pass it in with base 64 for it to be able to pick it up very well. It will be scripts / user data dot sh. And then that is it. Let's see if our instance has complete initializing. Yep, 3 checks has passed, so everything is running good now. Now, let me do the Terraform plan and add this user data file inside of my instance. But bear in mind that this wouldn't do anything because user data files are usually at the start of the instance is when it will go in and then do the installation of whatever that we want it to do. So this is the plan. This is the result of the plan. And this plan is actually going to be adding the user data to it. And then I'm doing Terraform apply right now. It's going to put it in, but again, just like I said, that wouldn't do anything. And after building it out, I will go to the AWS and test it for you to see that it will not work until I have to either restart that instance or replace that instance. But for the sake that this is an automation that we are running, I will replace the instance through this, and we'll see the command to do that. Just a simple terraform apply, but then this time around, you will pass in the replace function or method, and then with that, you will put in the name of the resource that you want to restart, which is AWS underscore instance dot test, which is just exposed in the line 1, as you can see in our code, why this is running. So I'm waiting. Yep. Everything is complete. As you can see, we have the user data created now. So one change has been made. You will see that when I try to click on the IP, nothing will happen, right? It's just blank, so nothing happened. So I remove it again, and go back. Okay. So now I'll do the terraform apply with the replace flag that I said, and then equals AWS underscore instance. Just like I'm saying, yep. Instance dot test. And then when I run it, it will force it to restart. And as you can see, you will see will be replaced. And after this replacement, when we go in, we will see that I will see that this has been created, and I can access it. It's still creating. Usually it takes a little time to destroy and then reapply it. Why is doing that? Let's look for the security group. And you can see I'm in the Terraform documentation for AWS. The security group, it should be in VPC. Yep, I see it. And then you can see the example usage. You declare the security group, and then you segment the security group, whether it's ingress or egress. You can separate it, or you can add it together inside of your security group that you've created. And that is exactly what I'm going to do. I have a bunch of security groups that I've copied. I intend to reuse it. So I will reuse it and make a tweak to a few things if I need to. So as you can see, the creation have finished, and now I'm adding the security group, and I'm naming that security group allow HTTP. The VIP ID is model.vpc underscore id. I can't remember bringing in any model here, so I'm just going to remove it and put it to data, and then just reference the default VPC. And I will call this the test VPC. I have not declared this data block, so I will do that right now under the security group, and I will just do that and give it the what I assume is the AWS default VPC ID, the default CIDR block. Sorry, good. Picking it up. I'll come down and then create it. Sorry, this is taking a little longer, but I hope you're following in and then you're understanding what I'm doing. If you have any question, please feel free to ask me that question in the comment section and I will respond to you. There is no question that I consider stupid, so by all means, feel free to do that. And then as you can see, I'm creating the data block and I'm adding the CIDR block. I believe it's going to be 172.3.1.0.0/16. Yeah. So I'm done. And then just to verify, the CIDR block is 0.0.0/0. Opening it up to the internet, and then the egress is the same. And then we have the user data that is already implemented with that replace flag Terraform. So let me go back to the Terraform instance. And what I'm trying to do here is to show you how Amazon expects us to add that instance in the instance block. So it will be VPC security group with the security group IDs, flag, exactly, security group IDs. So I do VPC and then it prompts me up, and that's why I love this. So I will do, no, it doesn't need to be in bracket, does it? AWS security group allow http.id. That is me telling it that this is the security group that I want you to use, and I'm getting that security group referenced under that file. So let's do Terraform apply again. Yes. Usually I'm supposed to do Terraform plan each time I run Terraform apply. So I run the Terraform plan and then, oh, sorry, I didn't run the plan. So I'm canceling it and I'm running the plan right now. plan will tell us what to add. If you see, we're about to add ingress, egress, and security group under a security group. You can see the security group that is trying to create. Now let me do apply. And then yes, it failed. And this failing this time around because of the security group name. Oh, I did forgot to change the name. So let me change that name right now. Do the plan. The plan came out successful. And then let me run the terraform apply. That's the plan. And the name has changed because I changed it. So good. Running the terraform apply right now. Then yes. And you can see it's creating us the security group. And then we have the security group. So with this security group right now assigned to this instance, we probably will need to go check, but I am confident that we can be able to access this web server using the public IP that it provides. So that's the instance that is running, and you can see the status check, everything has passed. So all I need to check is the security, and you can see that it has attached the security group. The ingress, the inbound will be the 80, and the outbound will be anything. So I just picked up the IP address, and you can see it works. Works. That's good. So we are making significant progress. What again I like to add is to create an output .tf file, and just to demonstrate one of the Terraform best practices, you see how I picked up that output. That output, I don't usually need to pick it up like that as a developer. So I want whenever I run the Terraform plan to give me back that public IP. And then when I get the public IP, I will try to call it in the terminal using the call command. And that's it. And the value that I'm assigning to this output is AWS instance.test.public IP for it to get the public IP. And then when I run the Terraform plan, you will see that is going to tell us that we are trying to get an output, yes. And then you see it here, yes. That's the resources that I'm going to get that output off of. So I'm going to do Terraform plan and apply. This time around, I'll just go ahead and apply it. Everything has worked. Yes. And they should give us the public IP, which is down there. So let me grab that IP. public IP. If you put in the private, shit, it's not gonna work. So you can see that it works beautiful. So we are making a lot of progress right now. The next thing that I will like to quickly touch on, especially um, sometimes as a senior guy, we run into this. We use the default tags to kind of segment our distance, our resources inside of the club. I'm just doing the git ignore file so that whenever I commit this into any GitHub repo, it will not be messing with some of the folders that I don't want it to mess with. Because the reason is that those folders will make that commit to fail. Because with those files, especially the state management file, the Terraform state files, it will always be a chunk of big data that will be more than the required stuff that they want us to do. So, yeah, let me add the default tags. What the default tags is going to do is simple. It will give all the resources that I've just created the same tag, which will be the environment is going to be test. The name, I'm going to change it. And if you're following up with the screen, you will see where that change is made or where we'll make that change. So I'm putting in that default tag. Now, it is important to know that with default tags, if you have a resource that has a tag already, that tag that is in that resource is going to be what will count, especially. So let me give you an example. I have a tag with name, and I'm naming it right now Apache-Web-server. And I have intentionally given my security groups a tag with the same property name, but this time a different name. So in the security group, when I run this and go check it out, I will see that that security group will return the name tag until I remove it you know and then Terraform apply that change that I removed it. That is when this default tag will kick in. So Terraform apply. Yep. Yes. And then he made two changes. And those changes will be to add in those default tags. And to verify that, we will go to the AWS console. When we come to the AWS console, and then I refresh it, since this EC2, you can see it has a name already, Apache Web Server. It didn't have that before, but let's go to tags. You can see that it has the two tags that I put in as a default. One was environment is test. The other one was name Apache Web Server. But then in this security group, you see environment is test, but name is allow HTTP because there I have another name in the Terraform default tags, but because this is different and this was in the resource, right? So what I will demonstrate now is that when I go to my security group and remove that tags, the tags that I have highlighted, it will adopt the default tag that I have just placed. And this is good for those of you planning to take the AWS certification. This is part of the questions that you might encounter during your cert. You see the change? It's changing that tag. And when I click it, I will see that the name has changed to Apache-Web-server. Brilliant. The next thing to do is, since this whole thing has been in the, what is it called? Yep. So we can see in the back end, I'm trying to show you the cloud formation that I used in creating the back end resources that I want to be working on. Then this is the first one, is going to be the AWS S3 bucket. And as you can see, that bucket has access control to private. I don't want it public. And then I'm blocking access, public access block configuration. Everything is true, as you can see. The server-side encryption is going to be the KMS key that I just created down there. That's the KMS resource. And then that is the tags, the policy, and the statement of the policy. That is an alias, and this alias is going to be for the KMS. And then I am also creating a DynamoDB to give it a attribute name lock and attribute type S. And what I'm trying to do here is to, you see the key schema, but just what you need to know is that I am trying to create a DynamoDB table, and that's the output, S3 output and the DynamoDB output for the names. Let me go to S3 and then you will see that. But the S3 will be the place where the Terraform state is going to be in, and that's the Terraform states that I've been working with previously. I will show you in a minute how I will generate a new one for this project. When I go to DynamoDB, you will see the DynamoDB and the table, the DynamoDB table that I created. It will be Terraform backend DynamoDB table, just like that. And as you can see in the partition key, it is lock ID. So I don't want any other person accessing the Terraform state when someone else is working on it already at the moment. So that's exactly what I'm trying to do there. In adding it, I will create the backend.tf, and then I will put in the properties for that backend.tf. And it's going to be a lot similar to the providers.tf file, but this case is not provider. This time around is backend. And as you can see, when I run Terraform plan, it gave me an error, which tells us that we will need to reinitialize this. And if I reinitialize it, as you can see, the error is gone. And it's asking us to verify. And I will type in yes. And it's successfully configured right now to the back end. And when I go to the back end, I will see that I have a test key that will be test Apache, which is the name of what I named the key in the back end. So bear that in mind. That's the test Apache. And that is what I just created. So that is going to be it for this lecture. Again, what we did is to create an Apache EC2 Apache instance with Terraform, and then use the best practices, the default tags, and all that. And also, we sent our Terraform state that is running in our local machine in the, what is it called? The S3 that we have created using CloudFormation. So that is it. Thank you.